Hi there, guys. All right, so at this point in the course, we should be starting our third and final unit of physics. Now, I know things are a little bit weird right now. Everybody's working at, a slightly different pace, but please don't start physics until you are completed ecology. All right, so ideally, I would like you to have downloaded the physics notes. In a perfect world, I would ask you to print them and follow along and write things as I go. If you can't print them and you don't have access to them that way, maybe just watch the video and fill in examples on loose leaf, or just watch the videos and maybe refer back to them as you do your workbook. Okay, so today we're starting physics. Now, physics is kind of all about studying how and why objects move and how they kind of interact with forces. Sorry. All right, in this physics unit, we actually have two sections, and we're going to separate them a little bit. So we're going to be starting with kinematics, and then we'll have a test at the end of that, and then we'll work into dynamics. Now, throughout the unit, we're going to be describing measurements with some graphing and some pictures. You're going to have to be able to read word problems. You're obviously going to have to calculate things, and you're going to have to understand equations and symbols. So like I said, we're going to be starting with what I'm referring to as physics part 1, kinematics. So that will be the workbook that we start with as well. Today's lesson is going to be all about scientific notation. You'll notice as you kind of work your way through the unit, every once in a while, you're going to come across a number in this format. Okay, this is known as scientific notation. Scientists often use this to write really large numbers or really small numbers in a more convenient way. So for example, this number here, written in that way, 7.25 times 10 to the power of 5, actually represents this number here. So it helps us kind of represent large numbers in a bit of a different fashion. So you're going to have to be able to convert from scientific notation, which is this one, to standard notation and back and forth and understand what those numbers mean. So let's take a look at the format here of scientific notation. There's a few different features here. You'll notice first, there's always a decimal number. The decimal is always after the very first non-zero digit. There's always going to be a multiplication symbol, and it's going to be written as times 10 to the power of something. Now this exponent or this power is allowed to be negative or positive, and I'll explain the difference for that in a minute. So first off, how do we convert from standard form, regular numbers, into scientific notation? Here's a couple steps for you. Step 1 would be to underline the amount of digits you want in your answer. We're not going to actually worry about sig digs, but just the kind of correct number of digits. Second, really important here, in scientific notation, the decimal always gets moved behind the very first digit that is not a 0. Okay, and we'll do some examples. Third, you write your kind of number, you write your times 10, and however many times you actually moved the decimal is the exponent on that times 10 to the power of. And I'll show you what that means in a minute. And if you need to round, make sure you do that properly. So any number 5 and above gets rounded up, and less than 5 gets rounded down. Now here's a couple little tips here. If you are starting with a number greater than 1, any number greater than 1, then that means your exponent on the 10 is always going to be positive. All right? You can also have negative exponents like we see down here. Those are used to represent small numbers that are less than 1. And we'll do some examples there. Okay, so this is really important to know. Your exponent is positive if your original number is greater than 1. Your exponent is negative if your original number is less than 1. All right, let's try a couple examples here. So what we're going to do is we're going to convert, these would all be considered to be in standard form. We are going to convert these into scientific notation using 2 digits. Don't worry about significant. All right, so here we go. In order to have 2 digits, we underline the 2 digits that we want. Okay, the 4 and the 6. Next, it says to move the decimal behind the first non-zero digit. Now we have to consider how many times, why isn't this working? Okay, so that's my number. All I've done is I've moved the decimal behind the first non-zero digit. Oh, sorry, I'm only supposed to have 2 digits. And because I only have 2 digits, my 6 actually rounds up. Now, obviously we know 4.7 is not equal to 468, not even close. This is where the exponent comes in. So now I write times 10 to the power of something. My power is however many times the decimal moved from where it was to where I've placed it, which in this case is 1, 2 times. Because my original number was greater than 0, my exponent is positive. Okay, so 4.7 times 10 to the 2. If I were to directly convert that, that's going to represent 470, which is close to 468.3. The reason it's not exact is because we've been restricted to only 2 digits. Okay, next one here. Underline the number of digits you're allowed. Move the decimal behind the first non-zero digit. 6.8. Write your times 10 to the power of. Oops, what's going on here? And however many times you move the decimal is what your power is. So it would have moved 1, 2, 3 places. Number's larger than 1, so my power is positive. Okay, next one. 7 and 6, decimal moves behind the 7. How many times did the decimal move from where it originally was to where I put it? 1, 2, 3, 4 places. Okay. The next 2 here are a little bit different. So my first 2 digits that are non-zero is the 9 and the 3. So my decimal has to get moved behind the first digit that is not a 0, which means the 9. So this becomes 9.3 times 10 to the power of, how many times did I move the decimal? 1, 2. But in this case, my exponent actually needs to be negative. Okay, because my original number is less than 1. So it's actually a negative 2, which would convert exactly to 0.093. Okay, so my exponent is negative if my original number is less than 1. Okay, same thing at the next one here. Now this is actually going to be decimals moving here, but then I have to look to the 8, and that's actually going to round the 6 up. Times 10 to the power of, how many times did it move? 1, 2, 3, 4. And my exponent has to be negative because my original number is less than 1. Okay, so that is converting from standard notation to scientific notation. Now we're going to do the reverse. We're going to convert from scientific notation back to standard. Now to do this, we have to look at the exponent. If the exponent is positive, that means you are going to move the decimal to the right that many times. If the exponent is negative, you're moving the decimal to the left that many times. Okay, very important. So here's an example. 4.53 times 10 to the 4. I'm converting this back into normal numbers. My exponent is positive, so I move the decimal to the right that many times, and I fill any spaces with zeros. So 1, 2, 3, 4. You'll see there's 2 spaces left, and I fill those with zeros. So that becomes, oops, oh, touch something. Oh boy. 4, 5, 3, 1, 2. So you'll see my original decimal was right here, and I moved it to the right 4 times, and I filled my empty spaces with zeros. Okay, next one, take a look here. My exponent is negative, which means I'm going to be having to move my decimal to the left 3 times. So that looks like this. So again, my original decimal was right here, and I had to move it to the left 3 times, and I had to fill in my empty spots with zeros. Okay, that's where we're going to stop at this lesson here. You need to go now to your workbook, work on page 2, complete all of page 2, and then start on page 3 as well. So you're starting with basically questions just 1 and 2. Okay, bye.